Hey everyone, 7.2 properties of parallelograms. So here we go, looking at this figure called a parallelogram, and that's going to be something that's going to be, we'll use that a lot this chapter in chapter 7. But we're going to be looking at some properties of the parallelograms. Before we get to that, let's take a look at a little comic strip. This is Calvin and Hobbes. If you're not familiar with this, Calvin is the boy. Hobbes is his kind of stuffed animal, but he pretends, and he pretends that he's a real tiger. Instead, really, he's just toting around a stuffed animal. So here it is. It says, I know it's a little blurry. Sorry about that. But Hobbes says, why are you digging a hole? I'm looking for buried treasure. What have you found? Hobbes says. A few dirty rocks, a weird root, and some disgusting grubs. On your first try, there's treasure everywhere. So, one of my favorite kind of cartoons has always been Calvin and Hobbes. All right, let's move on to parallelograms. So on page 202 of your notes, there's a vocabulary to fill in. So at the very top of 202, fill in for parallelogram this right here. Just write down what I've underlined. That a parallelogram is a quadrilateral with both pairs of opposite sides parallel. And you can draw this picture right next to it showing that you have both pairs of opposite sides are parallel. So you got the parallel marks there with these little arrows. So the PQ side and the RS side, those are parallel, and then the QR side and the PS side, those two are parallel. That makes a parallelogram. So it's a quadrilateral. Quadrilateral is always just a four-sided figure, quad meaning four. So it's a four-sided figure with both pairs of opposite sides parallel. That's the definition of a parallelogram. All right, let's take a look at some theorems now for parallelograms. The first one is the parallelogram's opposite sides theorem. So opposite sides are congruent, it says. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So these sides are congruent here. These are opposite sides. The ones that are opposite sides are parallel. They're also congruent as well. So these top two and the bottom two are opposite sides, and they're congruent. The other one here, parallel opposites angles theorem. So the opposite angles in a parallelogram are also congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. QS are congruent, and RP, which are opposite angles, those are also congruent. So if it's a parallelogram, if you're told that it's a parallelogram, or you can tell based on the figure here, like it's showing all the parallel marks here, that it's a parallelogram, then you know that the opposite sides are congruent and the opposite angles are congruent. Okay, so here's a quick little one you can see, finding x and y. Opposite sides are going to be congruent. So we can make a little equation out of this. These two will equal each other. That's what they're going to show right there. X plus 4 is equal to 12, and so that means x equals 8. And then the opposite angles are also congruent, so y is equal to 65 degrees. That's that there. So x is 8 and y is 65. Okay, so 1 and 2, problem 1 and 2 from your extra practice. Let's take a look. Find the value of each variable in the parallelogram. Starting off with number 1, opposite sides we know are going to be congruent, so we can set these two that both have x here equal to each other. We wouldn't want to start with these ones because we have opposites or just different variables, 4x and a y. That would not help us. So we want to look at the ones that have the same variable. So these are opposite sides that have the same variable. So we're going to set an equation equal to, so x plus 18 is equal to 3x minus 2. And so now we'll just solve this. So I can get the x's by itself, so the x's together over here. So we're going to see 18 is equal to 2x minus 2. And then we'll add 2 to both sides. And so it's going to give us 20 is equal to 2x. And just divide by 2. So x, we can see, is going to be 10. So x is 10. Now we can plug in 10 for x in this one right here. So it's going to be right here 4 times 10. 4 times 10. So that's going to give us 40 for this side right here. So if opposite angles are congruent, that means y is also 40. So we can say y is equal to 40. And there's our answer for x and y. Number 2, This one we're seeing some angles in here, so we can say opposite angles are congruent. We wouldn't want to go off of these sides because again we have an x on this one and y on that one. So we want to look at these opposite angles. Those can be set equal to each other. They are congruent. They're the same, and it just has one single variable, just an x. So we're going to look at that. We'll do a different color. So 4 x minus 37 is equal to 49, and so we're going to just add 37. And 4x is now equal to, what's that going to be, 16 there. That's going to be 86. And so we're going to divide by 4. And so x is equal to 86 divided by 4. So let's see, that's going to go into, I'm going to do a little side thing here, 86 divided by 4 if you need to. Almost look like a square root. So 4 goes into 8, we can see 2 times, and so we got 8 coming down here, and we just bring down our 6, and 4 goes into 6 one time, so it's 21, and 4 here, subtract that, we get 2. 2/4 is the remainder, so basically 2/4 is the same thing as a half, so basically it's going to be 21.5. is what we're going to see. We can do that by just making a decimal here and putting 0, bringing 0 down, and we can see that goes into 5 times. And so 21.5 for x, and so if that's x, we can go ahead and plug that in over here on this one. So we'll see that, I'll do a different color again here. So 4 times 21.5 minus a 3, and that's going to equal y over 5, because the opposite sides are congruent here to get those equal to each other. So 4 times this 21.5, that goes back to 86, so we come back to 86 minus 3 equals the y over 5, and we subtract 3 from this, so it's going to be 83 is equal to y over 5. Now we're just going to multiply both sides by 5. So this is times 5, so 5 times 83, I'll do a little scratch work up here, so that's 15, and 41, so 415. So y is equal to 415. So there's our answer for y, here was our answer for x. Okay, the next two theorems there in your notes. We have parallelogram, consecutive angles theorem. So that basically means that the consecutive angles, not opposite angles, consecutive are next to each other, they're going to be supplementary. So supplementary, which means they equal 180 degrees. So if we add up these two here, they'll equal 180. If we add these two up, they'll equal 180. These two add up to equal 180. These two add up to equal 180. So all the consecutive angles will add up to equal 180. The next one is parallelogram diagonals theorem. The diagonals is where you go from opposite angles. If you draw a line from one opposite angle to the other one, or vertex to vertex here, those are going to make an X inside the parallelogram. And what's that going to do is it's going to bisect these diagonals. So as we see the diagonals in here, the diagonals get bisected. So they bisect each other is what happens. And so we can know that this diagonal here is going to be, this side is congruent to this side, and on this diagonal here, this side here is congruent to that side there. They will be the same. They bisect, they cut it into two equal halves. All right, let's look at the next problem, number 3. Here's one with the diagonals theorem, in fact. And so if we have ones here, we can go either way, with either starting with x's or y's. I'll start with x. But we could start with the 2x plus 10. That's going to be the same thing as 4x minus 2. They will equal each other, and so with these diagonals here this way. So we can just make an equation now with 2x. I'll go back to blue. So we'll start with our 2x plus 10 is equal to 4x minus 2. And so we'll start with subtracting 2x. Let's do that. Get the x's by themselves. And so cancel there. 10 is equal to 2x now. 4x minus 2x. And then we'll add 2 to the other side. Let's add 2 here. So that gives us 12 now on this side is equal to, these cancel, 2x on here. So now divide by 2. 12 divided by 2 gives us 6. So x is equal to 6. And then we want to find out what the y is. So just another one with y. So another equation here. So it's going to be 5y minus 16 is equal to 3y. And so we can subtract 5y, bring it over to the other one. Minus 5y here. So it cancels those. Negative 16 is going to equal, if I take 3 away from 5, it's negative 2y. Now divide by negative 2. And so we get negative 16 divided by negative 2 will give us positive 8. So there's our answer for y. Here's our answer for x. Okay, quick little joke of the day. So what do you give a sick bird? A tweetment. So there you go, joke of the day. All right, moving on to our second half of that page. On your extra practice, it says that we're going to find the indicated measure in parallelogram MNOP. Explain your reasoning. Okay, so we just got to look at this. Here's our parallelogram. We're going to find all of these indicated measures. And it wants us to explain our reasoning, which just means go back to those theorems we were looking at and explain it with those theorems. So first of all, PO, and let's see, maybe I'll use a blue again. So PO is down here. So the opposite side of PO is MN, that has 24. So we know opposite angles or opposite sides are going to be congruent. So we can say, well, this PO, that's 24, and the reason why is because the parallelogram, I'll just put opposite angles, or not opposite angle, opposite sides are congruent. So parallel opposite sides theorem basically is the one we want to talk about there. And then we have OQ. So O to Q, that's this side right here. So that's going to be a part of a diagonal from this whole diagonal here. This side of the diagonal is 14, so we know this side is also 14. So we know that OQ is 14, and that's the parallelogram, para again, diagonals, just put DIAG, theorem. So that's why. NO, so we look at NO, so that's this side right here. Opposite side is MP, and that's 26, so we know that this is also 26. So 26 for this one, and the reason is the same reason as number 4, so it's going to be parallelogram, or para opposite sides theorem. And then PQ, so P to Q is another part of a diagonal. This side of the diagonal is 20.7, so this side also must be 20.7 because these are congruent. So PQ is 20.7, and that's the, again, parallelogram diagonals theorem. Now we go into some angles here. So angle M, or PMN. So PMN, that's this angle right here, this big one right there. Now if we look at the opposite one, the opposite says 59. The answer is not 59 for this one because that's only part of this angle. It's not the whole thing, it's just this little piece. So we want to look at this angle over here. This is the whole angle, and it says it's 68. So we need to look at the consecutive angles here being supplementary. So basically these are supposed to add up to 180. So if I subtract 68 from 180, so 180 minus 68, that'll give me my answer here. And if you take it away from 180, that's going to give you 112 degrees. So this angle right here is 112 degrees. And the reason why is the consecutive, so parallelogram, consecutive, consec like that, angles theorem. NOP, so we can find N, so there's NOP. So we're looking at this entire angle right here, not just the 59, but the whole thing. Opposite angles are congruent, so it's the same as 112. This is also going to be 112 for the whole thing there. So we can put 112 for this one. And the reason why is parallelogram, opposite angles theorem. OM or OPM, So OPM, so this entire angle right here we're looking at. So opposite angle theorem again with 68, so this one's going to be 68 here, 68 degrees, and the reason why is parallelogram, opposite angles theorem once again, same as the one above it. And our last one, number 11, is NMO. So N's right here, M, and then O is over here. So we're looking at this angle. Let me use a different color. So we're looking at just this side of the angle. So if we remember down here, this one said 59. So here's when we're going to use the 59. This is not a theorem from this lesson. It's a theorem back from chapter 3. We have a parallelogram, which means these sides are parallel. This diagonal will be like a transversal. So we have the situation where we got the alternate interior angles being congruent right here. So these are alternate interior angles. So this has got to be 59 degrees right there. So this is 59 degrees. And the reason why is the alternate interior angles theorem. That's why. That's from back from chapter 3. Okay, we have just one more to look at. I know you're thinking, well, we're done. We're down number 11. That's the last one. Well, there is one I need you to put in the notes section. So if you go back a page, we're going to do a proof right now. Back one page, on page 203. So on page 203, you have a notes section right there at the bottom of the page. Nice big section there to write this in. So you're just going to copy this. Just go ahead and copy given ABCD and GDEF are parallelograms. Prove angle B is congruent to angle F. So write this on the notes section. So this is in the notes section right there on page 203. There's two notes section. You can just probably put at the bottom that's a little bit bigger. You also want to draw this figure. So just do your best at drawing this figure. You can kind of go diagonal, kind of make an X here, and then just connect them here. Just write the letters around the outside of this so you can kind of have the figure and the given and the prove part. Okay, so the first thing to do is just to put down the given. Remember, that's always going to be our first thing. So when we go into a two-column proof, you're going to do your statements and your reasons. So you can do a little T-chart kind of thing there. Statements on one side, reasons on the other. And the first thing's always going to be the given. So we're just going to write that there in the given part. So ABCD and GDEF are parallelograms. That is given. Okay, so what we're trying to prove is that angle B is congruent to angle F. Let's look at where that is. So this angle is going to be congruent to this angle. That's what we're trying to figure out here. So what we do know is if they're both parallelograms, we know opposite angles are congruent. Right? So we know that obviously B and D are congruent, and F and D are congruent. We also can see right here is a vertical angle, so this side of D and that side of D are also going to be congruent to each other. Okay, so those are some things that we want to realize here. So we can say that angle CDA is congruent to angle B. So angle CDA is congruent to angle B, and angle EDG, that's this one here, is congruent to angle F. And that's what, if a quadrilateral is a parallelogram, then its opposite angles are congruent. That's what I was just talking about. Okay, so now the next thing we want to look at for number 3 is that angle CDA is congruent to angle EDG because of the vertical angles congruence theorem. Okay, we learned that all the way back, I believe, in chapter 1 for vertical angles. So that's what I just said here. These are vertical angles, so they're congruent as well. So the last thing now, we can do the proof for it. So now, we can show that angle B is congruent to angle F because of the transitive property of congruence. So it's just what we're doing here. So if this one's congruent to B and this one's congruent to F, then they're going to be congruent to each other. So basically that's what it's showing you there. If they're congruent, then those two are congruent to each other. So, and these two here are congruent. So if these two are congruent, then these two are also congruent. So transitive property of congruence. Alright, so that concludes our lesson here from 7.2, and you should be ready to go on to the assignment for this lesson. Alright, I'll see you later.